nonmetals. Remember, you can pause this PowerPoint at any time you need to. So metals, metalloids, and nonmetals. Where are the metals? They are here on the periodic table. You can pause this and take a minute and shade it in with your pencil or color it in with your colored pencils that you have. I color mine in the same as my periodic table that we did earlier, just because it makes me happy. So pause this at any time and do this. Examples of metals would be things like copper, gold, Au, tungsten, W, and cobalt, CO. Notice the first letter is capitalized, and if it has a second letter, it's not capitalized. Metals have a multitude of properties. They can be hammered into flat sheets, and this is called malleable. They can be reflective or shiny, and this is called luster, or they're lustrous, they're shiny. They can be drawn out into thin wire, which is called ductile, and they're really good conductors of heat and electricity. The last thing is that they're very, very reactive. The majority of metals on the periodic table you won't find in their pure state in nature because they're so incredibly reactive. The more reactive they are, you'll find the more reactive ones are over on the left-hand side of the periodic table. Okay, metalloids are kind of weird. Metalloids have properties of both metals and nonmetals, so they're kind of iffy, and they are over here in this little stair-step section. Usually there's a little dark line that separates the metals from the nonmetals, and the metalloids run right along that line there. So examples of metalloids would be boron, B, arsenic, As, antimony, Sb, and silicon, which is one of the most important ones, and that's Si, silicon. They have properties of both the metals and the nonmetals. Some are shiny, some are dull. Most of them are brittle. They're not malleable or ductile. You can't pull these things into thin wires or anything like that. And they're considered semiconductors of electricity. They're not great conductors. They're not poor conductors. They're just semiconductors. Typically, though, they're poor conductors of heat. Again, anytime you need to pause this. Nonmetals are over on the far right-hand side, with the exception of hydrogen, which is just basically on the wrong side of the table. The reason they put it there is because it has one valence electron, just like all the other ones in that group. Examples of nonmetals are helium, with 2 electrons, fluorine, which is one of the halogens over on the far right-hand side, sulfur, and chlorine. So those are examples of nonmetals. They can be solids, liquids, or gases at room temperature. So you'll find them in various states there. They are dull and non-reflective. So if you see any of these, obviously if they're gases, they're not going to be reflective. But if you see any of those that are in solid form, they're not shiny or anything like that. They're brittle. That means they can break easily. They're not malleable. If you take a hammer to them, they're not going to flatten out into a sheet. They're just going to break. You can't pull them into a thin wire at all. They're very poor conductors of heat and electricity, and there are some way over on the far right-hand side that are totally non-reactive, and those are the noble gases.